sp3d hybridization. In this type of hybridization, one is 3p and 1d orbitals of an atom mix up together and redistribute their energies. On account of this redistribution of energy, a set of 5 orbitals of equal energy is obtained. The orbitals thus obtained are called sp3d, that is 1 plus 3 plus 1, that is total 5. Hybrid orbitals. These orbitals are directed towards the 5 corners of a trigonal bipyramid. Therefore, this type of hybridization is also known as trigonal bipyramidal hybridization. Match the following questions and fill in the blank questions. Example: phosphorus pentachloride molecule. First step, atomic number phosphorus 15. 2. Electronic configuration by Aufbau principle. 1s2, 2s2, 2p6, 3s2, 3px1, 3py1, 3pz1. Then, in the ground state, phosphorus atom has only 3 half filled, that is 3px1, 3py1 and 3pz1. And to show the pentavalence, it must contain 5 half filled orbitals. Therefore, for the hybridization, the next step is the excited state. The 3s electron, that is 3s2, gets unpaired and transfer 1 electron to the 3d level. Therefore, this is the diagrammatic representation. 3s unpaired and promoted that electron to the 3d orbital, first orbital. Therefore, at present now there are 5 unpaired orbitals, that means 1 plus 3 plus 1. These 5 orbitals undergo hybridization known as sp3d hybridization, resulting in the formation of 5 hybrid orbitals: sp3d, 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 sp3d and sp3d. That is the diagrammatic representation of the hybrid orbitals. Now, these hybrid orbitals, that the shape and the geometry is shown here. 3 are in the plane, the same plane, but 2 are different. 2 are at right angles to the 3 hybrid orbitals. Therefore, the name, and these 3, 1, 2, 3, that 3 orbitals, the angle is 120 degree, and these are known as equatorial bond. We'll explain again once again this. Equatorial bonds means 1, 2, 3. Now the 2 other bond, that is one above the plane of phosphorus and another one below the plane of phosphorus, is the center, that center in the atom, phosphorus atom situated in the center. Therefore, one above and one below at right angles to the 3 equatorial bond, that they are known as axial bond. Therefore, let us see what is the description. Among these orbitals, 3 are directed towards the 3 corners of an equilateral triangle at an angle of 120 degree. That is the one I said, 1, 2, 3. 3 are directed to an equilateral triangle, the corners of an equilateral triangle, and an angle of 120 degree, that is 120 degree. And the remaining 2 stay at right angles to the plane containing the equilateral triangle, one above and the other below the plane. These are the 2, 1, that is one above and the other one below the plane. Thus, the 5 hybrid orbitals acquire trigonal bipyramidal shape with phosphorus atom at the center. Hence, this type of hybridization is also known as trigonal bipyramidal hybridization. that is sp3d is also known as trigonal bipyramidal hybridization. Match the following question. These hybrid orbitals overlap with the half-filled orbitals of the 5 chlorine atoms and to form 5 phosphorus chlorine sigma bond. The 3 phosphorus chlorine sigma bond lie in one plane at right angles to in an angle of 120 degree and are called equatorial bond. That is, I said 1, 2, 3 are called equatorial bond. This 1 and 2 are known as axial bond. The remaining 2p phosphorus chlorine sigma bond are at right angles to the plane containing the equatorial bond, one above and the other below the plane. These bonds are called axial bonds. The bond length of each phosphorus chlorine equatorial bond is found to be 204 picometer. Here there is a give reason question comes. While that of each phosphorus chlorine axial bond is equal to 219 picometer. Why? The reason for the difference in the bond length of two types of bond is that the axial bond pairs suffer more repulsive interaction than that suffered by the equatorial bond pairs. That means those who are lying in this in the plane, that 3 will attack this 2 hybridized orbital in a strong way. That means here there is the interaction from 3 to 2. That means 3 bond pairs are there. Therefore, the interaction is more on the axial length. Whereas this 2 axial bond only interact with the 3. Therefore, that interaction is less compared to the first one. That is the reason. Then the axial bond, the repulsive interaction than that suffered by the equatorial bond pairs. The 2 axial bond pairs are repelled by 3 phosphorus chlorine equatorial bond pairs, whereas the 3 equatorial phosphorus chlorine bond pairs are repelled by only 2 phosphorus chlorine axial bond pair. Therefore, a larger repulsion is experienced by phosphorus chlorine axial than the equatorial pairs and increases slightly the phosphorus chlorine axial bond length. That is the main reason. Consider the interaction of 3 towards the 2. And this is more because 3 are acting on 2. On the reverse, the 2 is getting attracted or interacted by the 3. Therefore, on one side 3 and on the other side 2. And on the second step is that the 2 are interacted by the 3. This is always stronger. That means 3 interacts with the 2 is more stronger. That is why the bond length there is slight differences. Give reason question is important.